Hi friends, welcome back to my channel. Still on Power Machines N5. Today we are doing combustion of fuel by mass. My name is Tepo. Please subscribe to my channel to make sure you keep on receiving videos like this. Click that notification button so that you will be notified every time I post a new video. So combustion of fuel. Combustion of fuel is basically the burning of fuel, and that is it. So I will try to explain the concept of this topic using an example from my textbook, which reads as follows. A sample of coal gave the following analysis. So they say a sample of coal, and then we know that coal is a fuel. And then one thing we know about fuel is that it is a source of energy. And then we continue. A sample of coal gave the following analysis by mass. 85% of carbon. This is what they're telling us. 85% of carbon. And then they say 6% of hydrogen. And then they say 7% of oxygen. 7% of oxygen. And then they say 1% of sulfur, and ash is 1%. So it's 1% sulfur, and then it's 1% ash. And then we were given a fuel which is a coal, and then they told us that the analysis by mass of the coal, this is the analysis of the fuel by mass. It consists of 85% carbon, 6% hydrogen, 7% oxygen, 1% sulfur, and 1% ash. So these are the ingredients of the fuel. These are what makes the fuel. And then we continue. Before, we have a shorter way of writing them. So for carbon, we write C. For hydrogen is H2. For oxygen, it's O2. For sulfur is S. And then for ash is just ash. And then we continue with the question. They say calculate from a first principle. And then let's write this here. We will look at it in a moment. First principle. The amount of oxygen required for the complete combustion of 1 kg. The mass of 1 kg. 1 kg of this fuel. They say calculate from first principle the amount of oxygen required for the complete combustion of this fuel. From this statement, it is clear now to us that for combustion to take place, we need oxygen. And then without oxygen, combustion cannot take place. So we need oxygen for combustion to take place. So that they say for complete combustion, so that we can say at the end of the day, we were able to achieve complete combustion. Of the fuel that we are dealing with. Complete combustion means now the fuel is completely burned. That is complete combustion. So mostly in this topic, we will be looking at the amount of oxygen that the particular fuel that we are dealing at that time needs to completely burn, which is complete combustion. So these properties these molecules that we are given, which we were told that they are what makes the fuel: carbon, hydrogen, oxygen, sulfur, and H. Only these three, which is carbon, hydrogen, and sulfur, will take part in the reaction of will be burned. Ash will not burn, and then oxygen will it's not going to react with oxygen. So oxygen will be used to burn the others. And then we continue. They say, assuming that the composition of air is 23% oxygen by mass, and that, okay, let's say, they say air, the composition of air is 23% oxygen, which is this. And then this tells us that the air, because the simplest source for oxygen is the same air that we are breathing. So the air that we are breathing consists of only 23% of oxygen. What happens to the 77%? The 77% is what we call nitrogen. So from the air that we are breathing, only 23% of it is oxygen, and then the other 77% is nitrogen. And then they say by mass, or is oxygen by mass, and that the atomic masses are carbon 12, and then the atomic masses that they are talking about, they are atomic masses of these molecules that they gave us. Since we said there is a shorter way of writing them, let's erase these names to create space. So I will just erase here. So it's carbon, if I'm not mistaken, and then it's hydrogen, it's oxygen, and then it's sulfur. It's 2. And then they say their atomic masses for carbon, they said is 12. And then for oxygen, they said 16. Okay, yeah. For hydrogen is 1. For oxygen is 12. And then for sulfur is 32. Those are the atomic masses of these particular molecules. We do not have a particular atomic mass for ash. And then here is what they said. They have asked us to calculate the amount of oxygen that we will need to completely burn the fuel that we have. So now we must begin with calculating the amount of oxygen that we will need. And I will erase this. So this is where you will start. The first molecule, since these are what makes the coal, the first molecule that we have is carbon. And then we know that to burn the fuel, we will have to oxidize it. Adding, we will need oxygen. And then in this case, the product that will be formed after the carbon has completely burned is carbon dioxide. It's called carbon dioxide. And then we substitute with the atomic masses of each. For carbon is 12 plus oxygen is 16 times these two. And then carbon again is 12 plus, and then oxygen is 16 times 2. And then we simplify, which will give us 32 and then 44, which we then divide throughout by 12. We divide throughout by 12 because we want the amount of oxygen that will be used to burn 1 kg of the carbon. and then we divide 32 by 12, and then it will give us 2.667 as equals to 3.667. So now this tells us that for every 1 kg of carbon, we will need 2.667 kg of oxygen to completely burn the carbon and form a product which is carbon dioxide, and then form 3.66 kg of carbon dioxide. And then we will take this and put it here. It's carbon. Let's write it here. Let's say carbon. The amount of oxygen needed is equals to 2.667 kg. And then now we come to our hydrogen. So we do the same thing. We say H2, which is hydrogen, plus oxygen, which is needed for combustion to take place. And then in this case, the product that we will have at the end is going to be H2O. But now there is something that says the amount of molecules on the left hand side must be equals to the amount of molecules on the right hand side. Meaning that if you have 2 hydrogens on this side, you must also have 2 hydrogens on this side. And then if you have 2 oxygens on this side, you must also have 2 oxygens on this side. But if we look at this one, hydrogens in this side we have 2. Hydrogens we also have 2 on the other side. Then we look at oxygen, we have 2. But in this case, in this side we have 1. So we will try to balance the equation. This is called balancing the equation, so that the amount of molecules are the same both sides. Now, because we want to add oxygen on this side, we will add a 2 here, because we cannot add it here. We cannot add a 2 here, so we must add it here. So these 2 will affect this O, and then we will have 2 oxygens. But these 2 will also affect this H, so that we have 4 hydrogens. And then to solve that problem, we must come to this side and put a 2 as well, so that we have 4 hydrogens both sides and 2 oxygens both sides. And then now from here we can continue and substitute. Hydrogen, we know that we know that the atomic mass of hydrogen is 1 times 2, which is this 2, plus the oxygen. Oxygen is 16 times 2. It's equals to 2 into bracket 1 times 2 plus 16. And then here it will give us a 4. And then here it will give us 32. And then there it will give us 36. Divide throughout by 4, it will give us 1 plus 8 is equals to 9. This tells us that for every 1 kg of hydrogen, we need 8 kg of oxygen to completely burn the hydrogen and form 9 kg of water. And then this is the number that we are looking for. We will come here and say for hydrogen, the oxygen that is required is 8 kg. 8 kg. And then we are left with sulfur, because oxygen doesn't react. Oxygen will be part of the oxygen that is needed to completely burn the molecules that we have. And then I will erase this and now do for sulfur. And then for sulfur, it's sulfur like the other ones plus the oxygen, and then in this case we will have a product which is sulfur dioxide. And then we substitute. The atomic mass for sulfur is 32, for oxygen is 16 times 2, and then say it's equals to sulfur 32 plus 16 times 2. And then here it's going to be 32, here it's going to be 32 as well, this is plus 32 as well, it's equals to, here is going to be 64. And then divide throughout by 32, it's 1 plus 1 it's equals to 2. Meaning that for every 1 kg of sulfur, we need 1 kg of oxygen to completely burn the sulfur and form a product which is sulfur dioxide, 2 kg of sulfur dioxide. And then we can come here and say sulfur, it's equals to 1 kg. And then we did for sulfur, carbon and hydrogen. We know now that oxygen doesn't react, ash doesn't react as well. Ash is will form part of the products at the end of the combustion. It's waste, so we do not need this one. So now we can erase this. So with carbon, what happens when you are trying to burn carbon and then that you find that you do not have sufficient amount of oxygen? In that case, the products that will be formed will no longer be carbon dioxide, but it will be what you call carbon monoxide. And then as we can see that this equation is not balanced, we have 2 oxygen here, we have 1 oxygen here, then we must try to balance it first. And then balancing this, we will say 2 here, and then this will affect this as well, and then we'll say 2 here. And then we have 2 carbon, 2 oxygen. And then from there, we try to substitute. We don't try, we do. And then plus 16 times 2, that's equals to 2. And then our carbon is 12 plus 16. And then we simplify. Here it's going to be 24. Here it's going to be 32. It's equals to be going to be 56. Yes, 56. And then you divide throughout by 24, and then let me check the answers here. The answers that we are going to get, it's 1 plus 1.333, it's equals to 2.333. So if we do not have sufficient amount of oxygen, the product that we are going to get at the end is not going to be carbon dioxide, but carbon monoxide. And then this now tells us that 1 kg, 1.333 oxygen is needed to burn 1 kg of carbon dioxide and form 1.33 kg of carbon monoxide. And then we know that carbon monoxide is as a result of insufficient oxygen in a reaction. So if they were to ask you in a question, what does carbon monoxide in a reaction or in the product of combustion represent? It just represents that the combustion was incomplete. So if they were to ask you that, what does carbon dioxide tells us in a reaction? It tells us that the combustion was complete, because here we had sufficient oxygen, but here we had insufficient oxygen. But because we know that carbon monoxide is as a result of insufficient oxygen, what happens now when we take the carbon monoxide, HO, and add oxygen? Now, because we are adding oxygen, it's like we are continuing with the reaction. The product now will be carbon dioxide, which will have first to to try and balance the equation. That's 2, that's 4, and then it's 2, it's 2, it's 4, it's 4. Yes, and then we substitute. It's 12 plus 16 is 16 times 2, it's equals to 2. Our carbon is 12 plus 16 times 2, which will give us, I don't know the answers, let me check, 56, 32, here it will give us 32, and then it will is equals to 88. And then we divide throughout by the 56, which will give us 1 kg. It's equals to 0.571 kg. It's equals to 1.571 kg. This tells us that if you had 1 kg of carbon monoxide and then you wanted to produce carbon dioxide, or you wanted to react it with oxygen, it will require 0.571 to completely burn the carbon monoxide and form a product which is 1.571 kg of carbon monoxide. So you can see that the oxygen that is required in this case is slightly less than the oxygen that is required in burning carbon, straight from carbon to carbon monoxide, because we are now continuing with a reaction that was started and left in the middle. So we are done with these things. Remember, the question that we are dealing with required us to calculate the total amount of oxygen that is needed to completely burn the fuel that we are dealing with its ingredients being these ones. And then we have these amounts. So what we know about this amount of oxygen that is required by the carbon, the oxygen, the carbon, the hydrogen, and the sulfur is that it is for 1 kg of each and every one of these. But the mass of the coal is 1 kg itself, meaning that 85% of carbon in 1 kg is equals to 0.85. 6% of 1 kg is equals to 0.06. And then 7% of 1 kg is equals to 0.07. And then with sulfur, it's 1%, 0.01. With ash, it's also 1%, 0.01 kg, mole, kg mole. And then now we take these numbers, because we are not interested in finding the amount of oxygen that will be needed if each and every one of these were 1 kg in the fuel. We are being guided by the percent that they gave us, the analysis that they made, and they find that 80% of the coal is carbon. And then we take the amount of carbon, the amount of oxygen that will be needed by carbon when it undergoes combustion, and its mass is going, it's 1 kg. And then we say 66.7 times this 0.85 to get the correct amount of oxygen that the carbon will need in our case. And then we get, I get that, let me check the answers, bear with me. Where are they? Oh, okay. And then we get that for carbon is going to be 2.267 kg. And then we take for hydrogen, let's say carbon, and then for hydrogen H2, we say it's 8 for 1 kg, but now we're not dealing with 1 kg, but we're dealing with 0.06 kg of it. And then from there we will say, I got my answer as 0.48 kg. And then we come for sulfur again. Yeah. For sulfur, we know that for sulfur it's 1 kg, but now we're dealing with 0.01, and then I got my answer as 0.01 kg. So now the amount of oxygen that is required by the fuel that we are burning, we are going to say this oxygen of the carbon, the oxygen of the hydrogen, and the oxygen of the sulfur. The sum of these oxygens, which is 2.267 plus 0.48 plus 0.01, and then I got that the sum of those oxygen gave me, I will go ahead and erase these ones because we already have them now here. The sum, the oxygen required now, is equals to the sum of this, and then I got my answer as 2.757. But remember, KJ, in the system we already have oxygen. What do we do about this oxygen? That oxygen is the amount of oxygen required to completely burn these three, without considering without the consideration of this oxygen. And then now we have to put this oxygen into consideration because it is already in the system. It is actually the first oxygen that will react with these molecules before the oxygen that will be let into the system externally. So from this oxygen that we have, we will minus the oxygen that we are already in possession of, which is 0.07. And then now I got my answer as as 2.687 kg. This is what they have asked us to calculate. So this is everything that they want. This is how you go about answering this question. But they might ask they might go further to say calculate the total amount of air, not the total amount of oxygen, the total amount of air. Remember, air is not oxygen. If they say they want oxygen, this is what they want. If they say they want air, you must calculate the total amount of air. Remember, we said from air, let me delete this because we no longer need it. Remember, we said from so the process that we went through is what we call the first principle. The process of calculating for carbon and then calculating for nitrogen, calculating for sulfur. That is what first principle is. Hence, they said that we must use the first principle. So now we have the amount of oxygen that is needed. Remember, we said from air, only 23% is oxygen, and then the other 77% of it is nitrogen. This is oxygen, it's nitrogen. So this amount that we have, it's the oxygen. We need the amount of the 77%, which we do not have at the moment, which is nitrogen. And then we go to say the amount of air required so that we can have 2.687 kg of oxygen, which is 23% of the total capacity of air. It's equals to the amount of air, which is 2.687 times 100, which is 100%. Okay, let's say the amount of air required amount of air required is equals to 2.687, which is the amount of oxygen that we require in this combustion, times 100 times the 23%, because we know that the air that we have, it's only 23%, the oxygen that we have, it's only 23% of the air that is needed, or that the air that we will have in the system. And then now we get the total amount of air. The total amount of air is going to be 11.683 kg. So if they were to say calculate the amount of air needed in the system so that we can have this amount of oxygen, this is how you go about calculating the amount of air. But if they only said calculate the amount of oxygen needed, this is how you go about it. So this is basically what combustion of fuel by mass is all about. And that is basically the end of our lesson today. Hope this video will be of help to you. Don't forget to like this video, share it with your friends, and please comment and tell me what you think about this video. If you are new here, don't forget to subscribe and click that notification button so that you won't miss other videos like this. From me to you, my name is Sulphur. I will see you on the next video, which will be a continuation of our today's lesson. Ciao.